So our last compound that we're going to be looking at is called molecular compounds. You can sometimes see them called covalent compounds as well too, based off of the bond that they formed. So a molecular compound is formed between two or more nonmetals. So we've looked at just a metal and a nonmetal bond before in the last 3 lessons. Now we're going to be looking at what happens when two nonmetals form a bond. So nonmetals are actually going to form covalent bonds. This is because they share electrons to get a full outer shell. This is going to create a covalent bond, which is a bond that results from the sharing of outer electrons. So let's take a look at hydrogen, for example. One hydrogen has one valence electron. The second hydrogen has another valence electron. Remember, in order to be full, hydrogen wants to have 2 valence electrons to fill that first shell. So since this one has 1 and this one has 1, what's going to happen is they are going to form a bond, and we're going to see a hydrogen molecule being H2. Fluorine, on the other hand, let's think about fluorine. We have 7 and 7. So all that we're going to do is we're going to share 1 pair of lone electrons. That's going to form our covalent bond, and we're going to get a fluorine molecule here. So the difference between ionic and covalent, ionic, you actually see the exchange of electrons, and it's the electrostatic attraction that's forming the bond. Here you see a sharing of electrons, and it's that sharing of electrons that's forming the bond here. Let's start with naming. So the thing with naming is we actually can no longer use charges to figure out how many of each atom. So before we were using that crossover rule, the crossover rule is not going to apply anymore because we don't see ions. They're not predictable anymore. We're sharing electrons, and it can be tough to predict how many electrons are being shared. So elements are then given prefixes corresponding to the subscripts or the number of atoms, and the second element is giving the suffix "ide." So what that means is in the name, we actually want to describe how many types of element we have. So for example, let's take a look at carbon dioxide. Well, carbon, I only have 1 C, so I'm going to go ahead and I'm going to call that carbon. I have an O here, so we're going to go ahead and call that ox. But remember, all of our endings are going to want to have an "ide" ending. Now, in order to describe the fact that I have 2 oxygens, I'm going to use a prefix. I'm going to use a couple letters to tell me 2, and 2 actually means di. So we would call this carbon, 1 carbon, dioxide, meaning 2 oxygens. On the other hand, we have CO. CO stands for, I see C, so carbon. I see O for oxygen, so we would call that oxide. I only have 1 carbon in this case, so since I only have 1 carbon, I would call that mono. So carbon monoxide compared to carbon dioxide. So it's going to be very important for you to remember these prefixes. So this is definitely something you're going to want to have written in your notes. We do have more than 10 prefixes, but in grade 10, you're only going to be dealing with the first 10. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, 10 is deca. You've probably seen a lot of these before in math as you went through with math. You've probably seen 10 for dec before. You've probably seen 8 for oct before. Even in the arms of an octopus has 8 arms. We've got a little asterisk here, and this just has to do with mono. The first element in the name never needs a mono. So for example, when we go back here, when we were talking about 1 carbon, we didn't call this monocarbon. We never have to put mono on the first element. We have to put di, we have to put tri, but mono, if you only have 1, you don't need to include on the first element. But down here, like in carbon monoxide, you do have to include it on the second element. All right, let's take a look at some examples. Best thing we can do is just get right into this. So let's take a look at OF4. So first thing that we want to do is we want to figure out what O is. So if I take a look at the periodic table, remember we are going to be dealing all with nonmetals now. So if I take a look at the periodic table, O is actually going to be oxygen. So we're going to go ahead and we're going to put oxygen here. I just realized you can't see my periodic table, so I won't pull it up again. Hope you have yours in front of you. And F stands for fluorine. So we're going to go ahead, we're going to put the fluor. But instead of calling it fluorine, I'm going to call it fluoride. Now all that's left is to go ahead and put my prefixes in. I only have one oxygen, but remember I never have to put mono on my first element. I have 4 fluorines. So if I go and take a look at my prefix chart, which I really hope you wrote down, if not, you will write it down, you're going to find that the prefix for 4 is tetra. So I would call this tetra fluoride. So overall, if I was going to say this name, I have oxygen, a nice big space, tetrafluoride. Now let's take a look at my second one. N stands for nitrogen, so I'm going to go ahead and put nitrogen here. O stands for oxygen, so I'm going to go ahead and I'm going to put ox. We always have that "ide" ending, so I'm going to put ide. And now I'm left with my prefixes. I have 2 nitrogens. Since it's more than one, I do have to put the prefix on the first one. So I'm going to call this dinitrogen. And in this case, I only have 1. But remember, I do have to put the prefix of 1 on the second one. So I'm going to say monoxide. Now, notice that I made the kind of executive decision to drop that second O, right? That's because monoxide sounds strange. So if you have 2 vowels together that are the same vowel, you're going to go ahead and you're going to drop that vowel. Same idea if you have an E and an A next to each other, you're going to go ahead and you're going to drop that vowel. Or an A and E next to it, you're going to go ahead, you're going to drop that vowel. Last one we're going to look at is Cl2O7. So we have chlorine, and O stands for oxide. So I do want to point out that since we're dealing with just nonmetals, notice that oxygen came second in both of these, but first in this one. So in order to figure out what to write first, you just write whatever element appeared first. So in this case, oxygen appeared first, so I'm going to write oxygen first. In this case, oxygen was second, so I'm going to write oxygen second. Last thing I have to do is my prefixes. So 2 for chlorine is going to be di, so dichlorine, and 7 is hept. So hept. Again, I'm going to make the executive decision to drop my second vowel. So instead of writing hepta, I've just got hept oxide. So naming, not too bad. You literally just write what you see. No crossing over rule here. Don't cross over your prefixes. It's not tetra, oxygen, mono, fluoride. You write just what you see. So next up, we are going to look at how to write the formulas for covalent compounds or molecular compounds. Again, you want to make sure that you're always dealing with a molecular compound. So you always want to make sure that you do indeed have 2 nonmetals. So you want to make sure that iodine and chlorine are both nonmetals. Another way that you can tell now that you are dealing with a molecular compound is you've got prefixes now. So if you see prefixes in the name, I see tri, I see di, I see pent, I see hex. You do know that you've got a molecular compound as well. So in order to write the formula, again, I'm going to say it again, there is no crossing over in molecular compounds. So you just write what you see. So I've got iodine. I need to figure out what the chemical symbol of iodine is. It's I. And I don't see any prefixes here. So I go ahead and I assume it's 1, but I don't need to write a 1. I've got chloride, which is chlorine here. So that means Cl for my chemical formula. And I see the prefix tri in front of chloride. Tri means 3. So my chemical formula for iodine trichloride is ICl3. Remember that 3 was written with chlorine. There's no crossing over in molecular compounds. So the tri is indicating the fact that I have 3 chlorines. Why don't you go ahead and pause the video and try diphosphorus pentoxide yourself. So phosphorus, the chemical symbol for phosphorus is P. So I'm going to go ahead and write a P. And I see di in front of it. That's the prefix for 2. So I'm going to go ahead and write a 2 there. I've got pentoxide. So O stands for oxygen. Pent is 5. So I'm going to go ahead and I'm going to put a 5 here. Now I do want to point out it's not pentaoxide. You had those 2 vowels that were together. So we went ahead, we dropped the A, and it's just pentoxide. Why don't you go ahead and pause the video and try the last one that we're going to do together yourself. Try sulfur hexaiodide yourself. So sulfur, the chemical symbol for sulfur is S. There's no prefix here, so we go ahead and assume that it's a 1. Again, we don't write a 1. And then hexaiodide. So I is iodide, and then hexa is 6. So I'm going to go ahead and I'm going to write 6, standing for 6 iodines. Now notice here that this is the only time with iodine, when it's an I, you actually keep the A there. So this in this case is hexaiodide. Iodine is the only time that you don't drop the vowel beforehand. Last thing that I want to look at is these things called diatomic elements. We did look at them in grade 9. This is technically a review, but I want to look at some of the most common molecular compounds that you're going to see. And that's these diatomic elements. So what a diatomic element is diatomic elements are elements that do not like to be on their own. So they are elements that are never on their own. They actually will form a bond with the other atom of the same element. So for example, oxygen never likes to be on its own. So oxygen, when it's by itself, is going to form a bond with another oxygen. So we're going to have O2. Here's the exception. When oxygen is in a compound, it's okay being by itself because it's in a compound. Oxygen by itself, unstable, there's going to be a 2 next to it. Oxygen on a compound, you don't need to write a 2 here. By doing this, you've changed water to hydrogen peroxide, which is actually toxic. So you don't need to write a 2 when it's in a compound, but anytime that you're writing an element by itself that's a diatomic element, you do want to include a 2 next to it. This is going to be extremely important when we are writing types of reactions, which is actually going to be our next lesson. So the last question is, how do I know when I'm dealing with a diatomic element? And we use this beautiful acronym here called Hofbrinkel. This is a list of all the diatomic elements, all the ones that don't want to be by themselves. So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Anytime you see them by themselves, di meaning 2, there's 2 of them. So H2, O2, F2, Br2, I2, N2, and Cl2. That ends our naming. So it is very important that you practice naming, and it's very important that you practice writing formulas. This is probably one of the most important things that's not only going to come out of chemistry, but science this year. So you really need to understand, moving forward in chemistry, naming and writing formulas. So make sure you do your assignment. If you have any extra practice, or if you want any extra practice, please reach out and let me know. And we are going to start types of reactions. Have a great day.